Harvesting modern agricultural commodities in today's world requires processing a massive volume of raw material at high speed. The operations driving this volume, farms and ranches, make up the production agriculture sector. This sector acts as the physical midpoint of the entire food and fiber system, connecting upstream input manufacturers to downstream food processors and consumers. While physical goods move strictly downstream toward the consumer, economic data moves in reverse. Market signals, price contracts, and consumer demands flow back upstream, directly informing what the farms produce. Using the agribusiness management curriculum developed by Dr. Solomon Galetta at Lincoln University of Missouri, we can map the exact economic mechanics governing this system. Occupying this central position forces farms to act as systemic shock absorbers. They take the direct financial impact from volatile global supply chains upstream, as well as shifting consumer demands downstream. Today, a single U.S. farmer produces enough food and fiber to sustain 165 people for an entire year. This output anchors global markets. Over 30% of all the corn grown on Earth is produced in the United States. Yet, achieving this volume has coincided with severe attrition. Over the last 50 years, the U.S. agricultural sector has lost nearly 1 million farms. The physical landscape of modern farming, its massive scale and heavy debt loads, are not cultural choices. They are strict mathematical requirements dictated by microeconomics. To accurately model the future of global food production, the analysis has to shift away from the machinery and focus squarely on the individual farm's constrained profit function. The baseline accounting is absolute. Net farm income, or profit, is total revenue minus total costs. Expanding this reveals the operative microeconomic variables. Profit equals output prices times quantities produced, minus input prices times input volumes, plus fixed costs. The critical constraint: farms operate in perfectly competitive commodity markets with zero pricing power. The global market dictates the output price. Farmers are pure price takers. If their operating costs double overnight, they cannot simply raise the price of their crop to compensate. The only levers left under the farmer's control are managing their input mix, deploying yield-boosting technology, and diluting their fixed obligations. Because the revenue ceiling is set entirely by external forces, long-term survival demands a ruthless optimization of inputs and a constant expansion of scale. Applying these variables to a standard 500-acre farming operation illustrates the risk. At a $5 per bushel price and $650 per acre cost, the farm yields $75,000 profit. A 20% price drop wipes out the margin, causing a $15,000 loss. A 15% cost spike drops profit to $25,000. This extreme sensitivity to exogenous variables means an operation can achieve record-breaking physical crop yields and still face bankruptcy if the market math breaks against them. If the operating margins are this thin and prone to sudden collapse, a farm needs a specific structural defense mechanism. The primary defense is extreme scale. By expanding the total acreage, the farm dilutes its heavy fixed costs across a much larger volume of production. The USDA Economic Research Service farm typology data tracks exactly how aggressively this structural consolidation has taken hold. This chart shows the agricultural disparity. Small family farms make up 89% of operations, but generate less than 18% of market value. Conversely, large-scale operations account for exactly 3.2% of farms, yet produce 46.5% of economic value. In statistical terms, this top-tier concentration requires vast, highly centralized infrastructure optimized for continuous throughput. The Economic Research Service data proves that massive agricultural consolidation is the direct mathematical mandate of operating as a price taker. Operating within that top 3.2% tier requires enormous upfront capital and the deployment of advanced technology. The massive industrial engine that manufactures and distributes the critical components for this high-yield agriculture is the input supply sector. This sector is also the primary cost barrier. By 2022, total U.S. farm production expenditures rose to nearly $453 billion. That capital flows directly into genetically modified seeds, synthetic fertilizers, specialized chemical protections, and precision machinery. The sheer size of these annual operating expenses makes it impossible for most farms to cash flow their inputs, forcing an absolute reliance on agricultural credit markets. As of 2023, the U.S. farm sector carried a staggering burden of roughly $519 billion in total debt. The upstream input suppliers function as a systemic toll booth, securing a massive share of the farm's potential profit months before a single seed goes into the ground. This leaves a highly leveraged, $500 billion sector highly exposed. When an exogenous shock breaks the math, the entire system faces insolvency. The historical record shows exactly what happens during these systemic failures. During the 1980s farm crisis, volatile markets and heavy debt led to massive foreclosures. To prevent total collapse, the system relies on a sovereign backstop. U.S. federal policy intervenes directly to support farm incomes and stabilize the national food supply. This chart tracks net farm income against government payments since 1970. It shows a counter-cyclical pattern, with subsidies surging to rescue plummeting revenues. In 2020, government payments spiked, accounting for over 46% of total net income. Managing this incredibly complex web of heavy debt, volatile commodity prices, and shifting federal policy requires a very specific skill set. To survive today, a modern agricultural producer must step out of the dirt and operate as a highly sophisticated, data-driven financial manager. The ability of one single person to feed 165 people is a heavily engineered, deeply leveraged financial achievement, maintained by constantly balancing the razor's edge of microeconomic volatility.